So this talk is called Without Warning, Keeping the Noise Down in Legacy Code Builds. You're not going to see a great deal of code in it. This is broadly about some things that we did to do exactly that. So without further ado, let's establish some context. What do we mean by legacy code? This is Michael Feather's definition. Legacy code is simply code without tests. That's working effectively with legacy code. If you're dealing with legacy code and you haven't read this book, go and read this book. It's a good definition, but what do we mean by tests? Okay, he's specifically talking about runtime tests, but we've got other tools in our toolbox for making sure that the code is of good quality and is going to work. We have static analysis tools, okay? And there's one static analysis tool that we all have access to, and it's static analysis in the form of compiler warnings, okay? This is very, very cheap. In fact, it's free, and you get lots of them, yeah? And legacy code base, you inherit a legacy code base, you're going to find there's probably a lot of warnings, okay? It's got a bit tired, and those warnings are going to range from, you know, the trivial to things that you really, really should fix, okay? And yeah, basically you wouldn't allow code with failing tests, yeah? You wouldn't have a code base with failing tests in it. So why are we going to allow ourselves to have a code base with warnings, okay? Because that's how it was when you got it. When we got ours, there were 6,000 warnings on every build. And yeah, you can't go and remove them all. You can't just go and sit down. We're going to stop development on features. We're going to stop fixing bugs, and we're going to remove all the warnings. No one's going to accept that. So yeah. We're already at the bottom. Let's make sure we don't go any further down. The only way is up. Yeah? So we can't make things worse. This is always the rule with legacy code. Don't make it worse. So when we make changes, we're going to write tests to ensure that our changes have the desired result, that we're not breaking anything, and we're not going to add any more warnings while we're at it. So how do we do this? Okay, easy. Yeah, just count the number of warnings at the end of every compile, and just make sure there aren't more. Yeah, we could put that in our build script. Just sort of like, you know, it would stash it in a file, and at the end of every compile, you'll just check the number. This is ridiculous, isn't it? This is stupid. It's not going to work. I mean, this strategy would be easily defeated by changing include ordering in a source file. Incremental builds are going to defeat it straight away, and I mean, this is a C++ project. You want incremental builds because, you know, we don't have time to sit around for 2 hours while the whole thing's building. So we need to establish a baseline, okay? We're going to set up a point behind which we're going to squirrel away all our warnings that we kind of know about, but we're not going to fix, yeah? So we're going to remove or silence them. And then everything else is not allowed. New warnings are not allowed, yeah? So how are we going to do this? How are we going to get to that point? So, know your enemy. Find out what warnings you already have. Yeah? So we've got to analyze the warnings that we've got, and we work out which ones we care about and which ones aren't important. And it's going to vary from team to team. It's going to vary from project to project, from the compiler that you're using, etc. Okay, so you're going to have to discuss it. But how are you going to get this bigger picture? We write a script. Okay, so we're going to basically take the output of our build, and we're going to feed it to a script called summarize warnings, and we'll get warning summary.txt out. And we make this part of our nightly build process, basically. So our nightly build is a non-incremental build. It's a full build, so we're guaranteed to get all the warnings that exist in the code base. We run this script over it, and we get this thing out at the other end. Now, I mean, if you're using, well, we are writing on Windows, so we're using MS Build as part of the build process. That's quite handy because you can tell MS-Build to spit out a file containing only warnings. But any other compiler, grep is your friend. And this is the sort of thing we can get out of it. Okay, so we've got it boiled down to warnings by project, and we can see that the GUI module is actually quite bad. It's got 5,780 warnings in it, and then we've broken those out by the type of warning. So most of them are, conversion warnings, and then there's someone at some point has decided that even though we're using Visual Studio 2010, we actually do have namespaced enums, which we don't. That sort of thing. And that's an example of one that we probably wouldn't care about. Okay. And again, we've got the capability of actually looking to see which one's the biggest problem. And yeah, that conversion one is the biggest problem. We can see where they all are. And, which files are the worst. These are our hotspots, okay? And you can see that data plot handler, which is actually a thoroughly evil file with a 4,000-line function in it. It did have a 4,000-line function in it. This is quite old, but yeah, that was horrible. But again, not a file that you could comfortably change, without putting tests around it, and it was GUI code, and it was very hard to test. So, we're going to globally suppress warnings we don't care about, okay? So again, you discuss this with the team. There are some, there's going to be some things which you're going to go, well, this is silly. We don't actually care about that warning. It's not important, so you'll just disable it. And what you can do in your code, you'll just change the build so that you basically say, ignore this error on the command line, on the compiler command line. Yeah, so that will be your build script, or that will be your project settings for MS-Build, whatever. Yeah. If you're getting warnings from third-party code, there are techniques that you can use. I did a lightning talk on this last year. You can use the STL port technique of basically intercepting headers in the include path and then disabling them. I'm not going to go into that one now. If anybody cares to know more about it, didn't see the lightning talk last year, just come and ask me. And then we can go and fix low incidence sort of risk-free warnings, yeah? So let's say there's sort of like 6 of these things, and they're in a piece of code that's either under test or that there's actually no risk it's going to break anything, you can do it. Now, you've got to watch out, okay? Because if you think that signed, unsigned conversions are low-risk changes, they're not. You can easily introduce a complete change in behavior by going and fixing those. So I would advise you don't. You actually work out what's going on, and you write tests around it. And then we're going to suppress the other warnings, okay? So we're going to do that in the code, okay? Not on the compiler command line. You can't do this on a file-by-file basis. I mean, particularly that data plot handler example we had, 4,000 lines. There's a variety of warnings in it, and we want to suppress them all, but when we add new code to it, we want to be warned if we've made mistakes, okay? So, how can we do that? So, MSVC has got this handy thing, pragma warning suppress, which does exactly that. It just says, don't warn me about the next one of these, and then re-enables it straight afterwards. Clang sadly doesn't. Clang has, you have to push your warning status, tell it to ignore something, and then pop it again. Yeah. So, I mean, this is okay, but really, I don't really want to litter my code with all this stuff, particularly in MSVC, because it's like, if I come along and read this later, was warning 4244 again? Oh, I've got to go and look it up on MSDN or something. And it's, oh, for Pete's sakes. So what was wrong with that line of code? I don't actually know. So we change it. Okay, so now our warnings are explicitly labeled. We know what that warning was, yeah, and we know we're suppressing it. Yeah. So this is twofold. This is a lot to type out, So I'm hoping that it would discourage people from going, oh, I don't give a shit, I'm just going to do this thing anyway. You're not going to do that. Yeah, this is a huge hint to you. You're doing something stupid if you're typing this out. And it also lets us, when we're reading the code, see what the problem was. Okay, and you notice that in Clang it's slightly different, and that is because we've got these macros. MSVC, it's nice and simple. In Clang, it's a bit of a horror. But again, that works, and you can nest these, and it's kind of fine. Yeah. And I have to freely admit, this has all been tested, and it's all being used in our code base, which is Visual C++. The Clang stuff I just put in there to make sure that it could be done, you know, in a nicer world. Okay, so how do we get all these things into the code? Yeah, we don't want to have to go and type that big thing because, again, that's a warning that you're doing something daft. So what you do is you get the summer intern to do it. Yeah, here you go. There's 4,000 warnings in this file. I'd just like you to copy and paste. No, right, we're going to automate it, of course. Okay, so we have another script called suppress warnings, and you give it a list of warnings to suppress, and you give it your source tree, and you give it the warnings. And that's it. You can now suppress these warnings on a case-by-case basis across your code base. And again, you know, make sure it's a non-incremental build before you do this. Right. So we've established our baseline. We've now got a code base where we've basically, you know, made it completely quiet, and we don't want any more warnings. So how are we going to ensure that people don't let them slipping back in? We make them errors. Yeah. Most modern compilers, you can say warnings are errors, and that's it. Okay. And you can do this on a project-by-project or a file-by-file basis, which means that you can actually introduce this thing in stages when you've got, you know, a bit of time to do it. So you don't have to do the whole project. You can do individual modules. You could do individual files. You could decide to tackle one particular warning that, you know, you're not interested in this particular area. And there's no big bang. You get gradually improving code. So here we go. Here's the summary. Warnings are a good static analysis tool, but only if they're not there already, because otherwise it's a needle in a haystack job. We're going to get rid of existing warnings, okay? So you either fix them or you ignore them. And you ignore them not by kind of going, you're actually telling the compiler not to tell you. And make new warnings errors. They're scripts, which are in PowerShell. Sorry about that. Again, working on Windows or on GitHub. And that's it. Any questions? Yes? I haven't measured that, I must say. Not noticeably. Not noticeably. I mean, we have a build time, soup to nuts, of about 20 minutes, and then all the tests take about 5. So, yeah. Dominic?
See, one slight pitfall with the more convenient Microsoft one.
Yeah.
To suppress the next one. If you do something which inadvertently fixes warning, it will suppress the next one. Whereas the Clang one,
you're probably right. I hadn't thought of that. Yeah, good point.
I guess you could do a build with all those macros switched off and then check that you got warnings everywhere there was a macro within a script.
Yes. Yes, you probably could. Yes, you can. Yes, you can. Yes, you can. Anyone else? Yes.
Once you suppress these, did anyone ever go back and fix anything?
We haven't yet. We've only been doing it for I'll be honest with you, this stuff's only been in place for a couple of months, okay? And yeah, we're very busy with other things. But what it has meant is that new code definitely doesn't introduce warnings.
Yeah,
So.
I know it's good. It's interesting.
And you can of course go and find all the old ones because you can grep for a potential bug. Sorry.
Yeah, we did a clang report about a year ago, and I looked at the build script, and someone put to do, I'll suppress these warnings now, but then not reported. That was a year ago.
Yes. Yeah, exactly. And I think there's a big risk with like going and suppressing them at the command line because it means that you're not going to see the new ones. And you know, so that's what I was really keen not to do.
Nice. Great talk.
Oh. Okay. Yeah, sorry. Later. Yeah.